draw the angle, and by that one inclination you draw a line, and whatever the magnitude is there, 20 kilonewton, you write 1 centimeter is equal to 5 kilonewton. So 4 centimeter will give you the 20 Newton. So from point A, 4 centimeter length you measure on the scale and cut it on that one line. Then that 4 centimeter last point will be given by B. Again at point B, draw draw the x-axis parallel to the point A and measure the angle of F2 and draw the angle from there and make a line, make a ray from that one, and again 25 Newton, so 5 centimeter length will you cut it, and again from the point C you draw horizontal axis, x-axis parallel to the AX or BX, and this will become CX. Here F3 force is 30 Newton. You have assumed that 1 centimeter is equal to 5 Newton. So 6 centimeter represents the F3 force, and this will become CD. Again you measure it, again you cut it. This way you are going and you have reached that point E. So how the resultant will come? You join point A, initial point and last point, starting from the last point and going to the last point. If suppose that by doing this one way polygon is there and you have reached in the third coordinate and fourth coordinate, then what it will happen? Your joining A direction will become different. Suppose that in third coordinate you have reached, after suppose that 10 forces is there and last force will come in the third coordinate. So your line will go into the negative directions, but you have to join initial and last point, you have to join. That will give you the resultant. Again you convert, measure the length of the resultant, and you measure the length and convert it on the scale. So you have assumed that 1 centimeter is equal to 5 Newton and you have got around 2.5 centimeter. So convert it into that one. So around 12.5 Newton resultant you will get. And inclination, you can measure it from the x direction to the resultant, whatever the inclination is there. So this way is the graphical calculations of the resultant. Okay, is it clear to you? Is it clear to you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, okay. So this way same thing it is written, whatever I have discussed. Another method is the analytical method. You have seen that the parallelogram law forces is there, represent R is the resultant, F1, F2 you have seen. F2 is represented by BC having some inclination with theta. This is inclined with alpha. Okay, resultant is inclined with alpha. So you convert F2 into the cos theta into that will give you the BC. So R is equal to AC AE square. You see here AE square plus CE square. Okay, and AE is a combination of AB in plus B, AB force 1, B is equal to F2 cos theta. So you put it and square it. You will get the final resultant. R is equal to square root F1 square plus F2 square plus 2 F1 F2 cos theta. And this way you can calculate the inclination, that resultant inclination you are showing that alpha is there. So tan alpha is equal to CE by AE. You can calculate this way also. So system of forces, characteristics and examples of that. Collinear forces means all the forces are acting in a line. Line of actions of all the forces acts along the same line. Forces on a rope in a tug of war. Coplanar, all forces are parallel to each other. Coplanar, all forces are parallel to each other. System of forces acting in a beam subjected to the vertical loads that the ceiling of the buildings or wall of the buildings, so ceiling force is acting on the walls of the building. So coplanar parallel forces is there. All forces are parallel to each other and lie in a single plane. Coplanar, like parallel forces. Same way, coplanar, concurrent force, line of action of all the forces passes through a single point and force lie in the same plane. Forces on a rod resting against a wall. Coplanar, non-concurrent force. All the forces do not meet at a point but lie in a single plane. Forces on a ladder resting against a wall. When a person stands on a rung which is not at its center of gravity. Then is the non-coplanar parallel force. All the forces are parallel to each other but not in the same plane. Non-coplanar means not in a plane but they are parallel. The weight of benches in classroom. Non-coplanar concurrent force. All the forces do not lie in the same plane, but their line of access passes through a single point. Next is the non-coplanar, non-concurrent force. All forces do not lie in the same plane and their line out of action do not pass through a single plane. So this is the system of force. Next is the moment of a force. Okay, I will discuss about the moment, then I will discuss about the Varigan's theorem. This is the Varigan's theorem and the equilibrium of the systems that we will discuss later. 1 minute.
Recording in progress.
So 1 minute. So in the engineering systems, wherever you have to create the rotational effect and some force is available by the gas pressure or by any actions. So first you have to generate the force and then you have to apply in such a way mechanism you have to find so that the rotational effect will be generated. That's why you are studying this. So product of the magnitude of the force, this is the magnitude, and the perpendicular distance of the point from the line of action of the force. So perpendicular distance, this is the perpendicular distance. So here this is, so if you will put it here, you will get the rotational effect about this axis and it will get rotated. The point about whose the moment is considered is called the moment center, and the perpendicular distance of the point from the line of action is called the momentum. So here d1 is there, the f d1 will come here. This here you are applying the force here, so this will become d2. So f d2. If you want that you are applying this moment but no rotation should be generated, then you have to find the resultant of these two moments and you have to apply that one moment in that other direction. Opening of the door, you are applying on the tip of the doors and that force is acting and you are getting. Okay? Direction of moment of the force. So thus it may be noted point lie. Is it clear to you, the student?
Yes, sir.
Chaudhary?
Yes,
Chaudhary? So I'm not seeing your name. Whatever I have remembering from that one, I am calling to you. Okay, so because a screen is there, so it may be noted that a point lie on the line of action of the force. The moment of force about the point is 0. The moment of a force has got direction is also. So someone will in the clockwise direction and M2 is the anti-clockwise direction. Depends upon the direction, the action of the force where you are applying. Because axis is the same and you have to keep in your mind. You have to keep in your mind clockwise direction. When you are opening a nut, you are putting the key in the lock, and which direction you are applying the force? Clockwise. So clockwise gives you the opening and anti-clockwise gives you the closing. So if any mechanical engineering students, I will tell him that open the nut, and by seeing the directions, I can calculate he has the knowledge of the moment and direction or not. So somewhere you are putting the spanner and giving in this one direction, that one directions. So when you have to open, you have to, from the arm, you have to apply the force in the clockwise direction. And when you are closing, you have to apply in the anti-clockwise direction. That you have to keep in your mind. So direction of moment, imagine the line of action of force is connected to the point by a rigid point pinned at the point and is free to move around the point. The directions of rotations gets the directions of the moment. If the force is taken in Newton unit and distance is millimeter, Newton millimeter, these are the units that you have studied. Two parallel forces equal in magnitude and opposite in direction and separated by a definite distance are said to be a couple. The sum of the forces forming a couple is 0 since they are equal and opposite, which means the translatory effect of couple is 0. See here. Okay. So this way we are applying. We will discuss in the next class. Okay. 1 minute. So 120 students is there. So Anurag Gupta.
Yes, sir.
So you understood that how you have to calculate the resultant of the two forces. Okay. Okay. You have made a group of this one mechanical ME 101 group. You have made WhatsApp group or not?
No, sir. No WhatsApp group is not.
Hmm?
So no